was looking up some stats. Yeah, we've sponsored 16 internships to date that I can count, and hired 12 of those full time, and about 8 of them are still with us full time, and then there's 3 more that are interning right now, by latest count. So really believe in the program and have a great time, just a great experience with it. So this class came about from I was TAing an early class and then taking some students on in for internships, and like Git is everywhere in our organization. So realized quickly that it's a very much not just a survival skill, but a career advantage to know Git well. And so that I found that to be the case for me is if you look at the repo, I comment on that a little bit about how frustrating it was at first to not really know Git. So hopefully today and tomorrow we can just have you know the basics of Git. I'm not going to go into the social media aspect. It's all github.com. I'll try to distinguish between which is which, because sometimes that's hard. The lines blur a lot once you start working with GitHub. But GitHub is not Git. GitHub is the social media thick wrapper around Git itself. But sometimes things go wrong that aren't clear, and all the social media is built on this really fairly simple data model that's critical to know if you want to be productive, and when you get off the fairway into the weeds, how to get back onto the fairway with Git. So with all the changes in the curriculum and everything that's going on, hopefully that much will come across in these next few hours with Git. So I did put out the pre-work. Apologies that it was only on Friday. Still working on it. But hopefully you got a chance to at least look at that. And we'll go through and retouch quite a bit of that. The basic idea of this course is that you form project teams. Are those already formed yet, Tom, or do we still need to do that? We got on project teams?
Yeah, there's 4 to 5 students per team. I don't know if that's too many or
Perfect.
too few. Right.
Yeah. Yeah, I mean, we want to replicate the kind of the experience that you'll have when you actually have to use Git in anger, down the road for your final project. I mean, you don't have to use Git, but I highly recommend it. It'll help you if you can have a grounding in it. So that's what we're trying to do here. So we'll ideally be making changes, seeing merge conflicts and all kinds of things go wrong, and learn how to fix those things. Now, when it doesn't matter quite as much and you don't have all these other things to think about besides trying to make Git work for you and be your friend. So with that, I think one of the first things to do is if you haven't downloaded the Sourcetree app, go ahead and do that. Hopefully that's there for you. You don't have to use Sourcetree. You can use anything that shows a graphical Git representation, but I found that to be fairly easy to install and use. So sourcetreeapp.com is the place to go get it. Let me know if you have any issues with that, but it should be fairly straightforward. The way that the project will be set up is your team lead will fork my repo. So let me start sharing here. So this github.com/walquis/tags. Can you guys all see that okay? Can I see? Okay, yep. Good. Can I see chat? There we are. Let's see chat at the same time. Keep track of what's going on. So that's the repo. All repos on github.com are structured as github.com, and then you have the next element of the URL is either your username or a organization name. So Users are kind of like private orgs. It's a little bit weird the way they do that, but it's going to be user org here. And then the next level is the repo. So there's only these two levels, user org and then repo. And then permissions and ownerships and all that are structured mostly at the org level. You can also have specific repos that you invite people to collaborate on. But anyway, that's where we're at. My repo. There's a README that shows up and it's rendered in with Markdown. So that's what you're seeing here. I directed you to a thing called pre-work. This is kind of meta. This is not Git. This is just GitHub stuff. I said I wasn't going to cover that, but here I go. If you'll notice the link to that, it's not github.com. It's github.io, and it has a subdomain which is my user. So what in the world's going on with that? Well, see this here. What's going on is you can actually make a simple website in Git, and that's what I did. GitHub, which is what I did. And if you notice this docs directory, the source code, if you will, for all these docs on GitHub.io is kept in this docs directory. And if you make that in GitHub and you go there and put stuff in there, that's just basic. Kind of actually just shows the rendered. Let me show you the raw source. If you make stuff like this is Markdown. This is what your README looks like as well. But you can make your whole website like this. Then it will go and render that for you, and you get your own website. And that's what all this is. Anything under walquis.github.io is just that docs directory pushed up to GitHub, and then GitHub knows what to do with it from there. So just an FYI. So back here at our repo root, the README. Yeah, so what should have happened or can happen still is that your team lead will fork my repo. So you won't actually clone directly from here. And you could, but it would mess you up later. So if you're here on tags, Walquis/tags, you could go here and just, make yourself a clone using this URL. But if you do that, then you can't push back up, and that would not lend itself to project work. So that's why I say have your project leader do that first, and then you can clone your project leader's repo, team lead repo, and then he can add you. So like this is public. So if this were a clone, I could go to settings as a team lead and manage access, and then I can give people access, right? Based on their you have to the team lead has to know your GitHub handle, but once they know that, you can get access, and then for the rest of this class, your team will collaborate on that team lead's fork, if that makes sense. Any questions on that thus far? So team lead make the fork. Everybody, including the team lead, can clone from that fork, and then we'll be on our way to doing some collaboration.
So to clarify, you said the team clones off of your fork. They don't fork off of your fork?
Correct. You'll need one place to rendezvous your changes, if you will, and that will be your team lead's fork. I'm not going to accept any changes to my original repo just because it would confuse me, and there will be 30 some of those as well if everybody did that. So that's just more kind of a class setup exercise than it is knowing a whole lot about Git, but it's important so that your team can collaborate on that one place. So by the way, when I say fork and things like that, fork is a GitHub concept, not a Git concept. So what's happening with a fork is GitHub itself makes a copy of this repo and has its own sort of database schema on github.com that connects this network. And so when you see something like fork up here with an 83 next to it, then that's all GitHub. That's not Git. There's 83 forks somewhere of this repo. But that's the social media wrapper layer. When you do a clone, that is Git. So once you go down here and copy this URL, you can go down and do a Git clone. Let's see, I forget whether it actually does the Git clone. No, it doesn't. So you have to say Git clone if you're the team member and you have your team lead's URL. Then you can do something like that. Just paste that in, and first you'll want to be in a place that you are comfortable putting your repo. So I'm in home directory down under SRC and CP for code platoon. So I'm going to go ahead and do that. And you can too if you've got your team leads fork URL. And so this is Git. So feel free to go ahead and do this if you haven't done this yet. If you've cloned from somewhere besides your team leads fork, just get rid of that, rename it, and put it somewhere else so it's not confusing you, and get your team leads URL to clone with. So okay, got some comments coming here. So Bitbucket, I'm not clear on Daniel, what you mean by Bitbucket Cloud, or is that a source code viewer?
Yeah, that was for Sourcetree. After I downloaded Sourcetree, just the initial setup.
Oh, okay. Yeah, they probably want you. They're pointing you at various GitHub flavor alternatives to GitHub. Let's go ahead. First do your Git clone, because that's what you're going to point Sourcetree at ultimately. I haven't downloaded Sourcetree in a while. Hopefully it's still the same. But you've got this clone, and now this is a Git command, and it is down the complete copy of the repo. We'll go into that a little bit later, but that's not just the latest. It's all your repo is down there, including all the history. So let's see. Let's try looking at it with Sourcetree, since I've been talking about that. So here's my Sourcetree, and there's a couple ways you can tell Sourcetree about your repo. One is it says you can just drag a folder in if you know where that's at. So you could go to your Finder and then just navigate down, I can navigate from my home directory down here to CP, and then there's my tags repo that I just cloned. So I can drag that over. Now it knows about it. If you want to do that directly from Sourcetree, you could just go to New and choose Add Existing Local Repository, since you've already cloned it. At least follow this procedure. So then you go there, and same deal, you navigate down through your file structure to the repo. But anyway, once you've got it, you can double click on it and see graphically what's going on with your repo's history. So anybody having trouble getting to that point?
I just had a kind of quick question for us on Linux. If we're using Git Kraken, is that okay? Is there any issues we'll have?
What is Git Kraken?
It seems like pretty much the same thing as this. I was hoping you'd be
familiar with it. Anything that will give you a visual representation. Yeah, totally fine. Just ignore whatever I say that's Sourcetree specific, but as long as you can see something like this, you're good to go. Your colors may vary, but they might vary anyway. So cool. All right, so this is the repo. You should be on your, have your team leads fork clone down. Now you're local, but you're seeing things that are representations of what's up there. So let's now from here divert a little bit toward like talking about the layout of the repo and what the project will be like for your team. Is there any count of how many projects chose the mild versus the spicy version of this whole thing? It's kind of a new concept I introduced based on feedback from the last class.
I think mild sounds boring, so I guarantee everyone chose spicy.
All right. All right. Well, we'll buckle up then.
What have you done, Kevin?
Yeah, whoa, speak for yourself.
So Candace says, how did you connect again? So you don't actually need to connect anything remote. That's probably asking you about some remote stuff here. You probably in Sourcetree you want to click local. I may have neglected that step because since we've cloned our repo, it's going to be local. So we're looking at just what's on your own hardware right now, and so be sure that that's what is reflected on your source tree. So I would have to reinstall Sourcetree probably to recreate the exact experience you're getting. So maybe I should have done that. Point for next time. But yeah, so mild spicy. So you can totally like pivot if you want to, but I will say the spicy gave people trouble last time because it was just, there was more to it than just Git, right? It had to do with setting up your Python solution and your web server, and just more machinery involved. Did anybody try that and have any trouble with it, just by the way? Getting the Python web server installed?
I had a small issue after I got it up and running where I couldn't close the server, and that has caused issues like lasting until today, but they should be resolved.
Like it literally wouldn't stop running?
Yeah, it just kept the port open and I could not close it.
Okay. That would be a problem. Even after the process had died?
Yeah.
Okay.
There's an experience, but we got through it.
Yeah, an alternative there is you can actually select another port as well. If you want to just like, I think it's set up for 8,000. You can choose 8,001 and just go on your way as another option as well with a command line, some command line goodness there. Did anybody choose mild? If not, I'll just abandon the mild and go with spicy.
Oh, we chose mild.
Okay. Mild going on. All right. Good. Then I'll stick with mild. So you spicy folks, I won't say you're on your own, but I'm going to focus on mild, and you'll have to let me know if spicy's giving you trouble. I tried to make it the same website. If you were to go through both of them, they look quite a bit the same. But mild does as much as it can without being a web server at all. Like it's only an HTML page. So you'll get plenty of chances to, have Git collisions, merge collisions and all that with just static HTML and, CSS changes, etc. But if that's not enough for you, then you can certainly go the spicy route and get, collisions with code on your web server as well. But either way, we'll get plenty of Git exercise. So that's what I'll focus on then is the mild path. And if you look on Sourcetree, you can kind of see what's going on with each one. In mine, I'm not sure if your colors are the same, but in mine, there's a common ancestor master, which is where you'll be at right now. And one way you can tell that is you can see, you should be able to see, head is down here. So if I CD down into my tags directory, notice even though I cloned it, I'm not actually in that directory. It's there right ready for me to go into, but I have to actually go into it. So I can CD into it. And that's where I'm looking at right here. So let's see, what should we do next at this point? Let's do a little bit more environment setup. This is going to help me to teach Git. It's nothing you need to necessarily do to have to use Git, but it's some shortcuts and one little repository, I'll say adjustment that makes what's going on with the repo more clear as we kind of dive under the covers. So the first thing we'll do, and this is covered in the a later handout, but I'll touch on it right now. If you do an ls at your terminal, actually I didn't cover this. Does everyone know how to open the terminal on their machine? I sort of started here, but yes. I should have specified, yeah, we're on terminal.app if you're on Mac, or maybe you've got the equivalent on Windows, but some sort of Linux prompt or Unix prompt. So yeah, do an ls and see what's there. I've already CD'd into my tags directory. And there is, among other things, a bin directory. So we can do ls space bin. And I want you to run this command in this shell script in the bin directory that adds aliases for you. So you can type verbatim bin/git, type bin/git -aliases.sh. And nothing seems to happen. Ideally, if it does, probably something's wrong. But if it just does that, then you're hopefully good to go. And one way you can verify that is by typing an alias. So one alias that's there in place now, or should be, is called GS. So if you type GS, you should see something like on branch master, your branch is up to date with origin master, nothing to commit, working tree is clean. Anybody not seeing that?
I got GS command not found.
I got that as well.
Okay. And your bin get aliases.sh seem to work?
Correct. There is no error message with that.
Interesting.
Sure.
Okay, let's try a slightly different approach. So you can see the contents using cat in Linux. So you can say cat space bin/aliases.sh. Wait, no, you can't say that because it's not there. Git-aliases.sh. So this is what should have happened, is that this went and did these things for you, these are basic shell commands, alias commands. Alias is a built-in shell command. So the next thing I would try is copying this bottom line where it sets the GS alias, literally copying that and then pasting that and see if that works.
Well, actually, I got to work when I sourced it.
Okay.
So I just, yeah, it worked fine.
Excellent point. Yeah. Yeah, that's exactly right. That's a step I forgot. So we get to learn more about Linux, including myself. So does anybody want to explain what source does? Does anybody have a good handle on the source command?
So I believe when you run source, it's like reactivating the shell and then importing a bunch of stuff in there. So like all your aliases will import into your shell, and usually it's more with paths. Or I understand it more when it comes to paths. When you source a bunch of paths, it'll add all the paths to your where you can look for new applications and stuff.
Okay. Yeah. Yeah. So yes. So the bin aliases worked in a sense, like it ran, but it ran. What the shell does is when it gets a shell script, it spawns a new shell on top of your old shell. and then it runs everything inside the new shell, and then it exits, and then all those things go away. So, and they're not there. But if you do source, then it says, no, just use my existing shell and do the things that would be done in this shell, not another one of, not a subshell, if that makes sense. And because you're in your shell, then it just sticks around. So if you say source first, then it will run inside the current shell, and hopefully that will now work. So it worked for me because I already had it in, I have a different environment, so my mileage varied. But for you guys, yeah, source. How about now?
If we had already been in there and already checked out a different branch previously, should it default to that branch if we did this correctly?
If you haven't like changed your branch or checked things in, if you just go back in there, yeah, then you should be still good to go. You can run this, run this from where you're at. You should be on master. There's another alias. If you're getting Ghost script, then you maybe did not type source first.
So sorry, there's a different issue. I was sent to branch sample solution automatically. Is there something wrong, or is that what's supposed to happen if I was already doing that?
You probably had checked out that branch at some point.
Yes.
So that it would remember that. So you would have to go like Git Checkout master to get back on the master branch.
All right, I just wanted to make sure that that's normal behavior. What happened with mine?
Yeah. Yeah, if you've changed branches, then your repo totally remembers where you're at. Yeah, so if you get Ghost script for GS, that means that you don't have the alias set, because the alias would override the any other command it might find. So probably just need to type source and then the bin get aliases.sh. Okay, so that should be there. So we have GS. We also have, if you've done the cat command, you can see that we also have Git Add has been aliased. I don't like to type much, so you can tell this. Git branch is GB, so you can type GB and see what branch you're on. When the time comes, you can type GC for Git Commit. And if you really don't like to type Git Checkout master, you can type GCOM and so on and so forth. Okay, so now we should have aliases in place, and those are all all there for us.
Chris, how do we check if we did it right? Like, what was the command to check if we did it right?
Just try one of those aliases, like anything before the equal sign. So if you can type GB should work, or GS for Git status.
Okay, thank you.
And it should, it would literally do the exact same thing as if I type Git space status. Right, those should come out the same, which tells you the alias is functioning for you. Okay. All right. So yeah, the next thing. So this is another kind of housekeeping command that will help us later understand Git. If you look in the bin directory, ls space bin, there's a couple other things there. We're going to use this unpack objects. So this, we did not have to type source because we're not actually modifying our bash environment. We're actually running commands that are going to affect our directory. So we don't really care what bash shell it runs in. So we can just type bin/unpack. And your terminal should support tab completion, so you can just type tab if you type part of that script already. And you should get that, that message unpacking objects. So I'll show you what that's doing later. If you do find aliases confusing, don't use them. It's not an essential part of Git. It's just a bash convenience. So With that said, anybody having any trouble with the unpack objects script at all? Is that working for you? Awesome. Thanks, Guillermo. Okay, so let's see, what should we do next? Let's move around and look at some stuff here. We can see it in Sourcetree. You'll notice these branches that I at least stroke red for me are mild branches. So we're going to focus on those. There's some roughly similar spicy branches that are blue. The ones that those don't have the word mild on them. So that's spicy. Everything up here is going to be the track you guys are going to follow if you're on the spicy branch or the spicy path. But these guys are basically, the idea is that your team will make these changes only not in sequence. Like you see these branches representing sequential changes that change the page. And they all, if you follow on through, it all just works. So for instance, if we jump ahead to this guy, let me change my source tree a little bit. Okay, so we see we got one file changed. We had one line change in that file, and that was a line that is now there that wasn't before, right? So we can actually go there because we're not there right now. We're on head. So we can do a Git Checkout, and Git does a thing for us, which if we just say one-mile-hello world for a branch, these are each branches, by the way, we can, I'll show you what it does. So with one-mile-hello world, and if you typo it, it'll tell you, no, it's not there. But if you get it right, it will say this. So that's what it says. Let's see what it looks like in Sourcetree. So what's different about that line that was than 10 seconds ago? Anybody pick that up? That line in Sourcetree that I've highlighted here.
It says hello world.
It does. So I have to comment. Go ahead.
Make like a copy. I got like a second little file there.
Yeah, so there's a copy branch. There's another branch there, right? There's one that has origin / 1 mile hello world, and now there's another one with just 1 mile hello world. So so what happened there? Anybody got any ideas what just took place?
Did we just pull did we copy the origins and it's one we can play with and push it back to the origin?
Yes, so yeah, very much so. The origin is a concept that Git maintains that basically has to do with the distributed nature of Git. So origin actually represents github.com. So that's the thing that points to github.com is origin. It's called a remote. So if we do, let's go back here a minute and play with that. So if we say Git remote space, let's we do that. Okay, that's kind of where we're defaulting to now is on origin. And if we do a -v for verbose, we can see a little bit more about it. This is where we clone from, right? That's it. So that's what, when you say see origin something, that's the name of the remote that branch lives on. So if we're on that, that remote, which Git knows we are because that's where we clone from, and we say Git Checkout without that origin / whatever, then it knows to set up they call it a tracking branch, right? That's why they say set up to track remote branch. So we cannot actually change the origin / branches directly. Like we can push to them, right? When you say Git Push, you specify a remote. Well, I'll get to that. but you can't actually change them. They're just markers for you. So when you do a checkout, then it makes a local copy. So this thing here is a local one that we're looking at. And same, if you look down the line below, you see where it says master. That's the exact same thing going on. Is that when we check out master, we're actually checking out that local copy. We're on this guy, not this guy. Even though they happen to point to the exact same code, right? The exact same commit right over here. But they're, you know, they're tracking different, they're tracking your progress locally. This master branch, like if we were to make commits here, this thing would move, but that thing would stay there until we were, you know, pushed over to it to update it. So it's kind of a, for me, it was a bit of a, I don't know, it was hard to grasp at first, but just, you know, it's important because that's how Git tracks where you're at. So as long as we're on the same page, it doesn't matter if we're lost, right? Okay. It'll all become clear as we go through the next 5 hours. Don't worry. So this is all just kind of looking around. We haven't made any changes. You do notice that because I've done a Git checkout here, at least the way Sourcetree does it, Git Kraken might do different, but Sourcetree has this little dot here that represents my current branch. See that dot there? So if I were to go back and do a Git checkout master again, and then look back here, see it updated. So now the dot moved back here where master is down here. So we're exploring these different places by checking out different branches. And as you see on the diff here, this is the difference between this place and the place before it, right? So this is what's changed since this checkout here, the 38D C3D7. Okay. Let's see if we can get your hands on the keyboard a little bit at this point, more than before. So what is it, 140? All right, so so let's think of a thing that your project team can do for maybe the next 10 minutes, and then take a break, and then we'll sort of get back together at a little before 2, maybe right at 2 o'clock. So so do this. Make sure your project is on, your team is on the same page first. Make sure you've all got, you know, the right thing cloned down from your team lead's URL. Make sure that you've run the bin unpack objects, and which you can't really tell if it worked, it just worked. And then make sure that you're on the branch here, which you should be. You can tell from the source tree if you're not. You can also run a git branch or GB, git space branch, and that tells you with this star here. This is the branch you're on. So if that's all in place, try making 1 or 2 of these changes. For instance, this hello world. You don't have to like go to this hello world branch. That's just there to show you what change, you know, would add a hello world to your project. So if you don't want to, you know, you don't have to use that. You can just go to master. Here's what I suggest you do just to warm yourselves up. You know, make sure you're on master. Check out master. Already on master, good. So where's the change? It's in mild. Notice it's in the mild directory is what you guys will be working with. So I would CD to mild, and I would look around with an LS, and I would, I think you guys are using VS Code, right? So should be able to say code space tags dot HTML. And wait a little bit, and there it comes. Don't need the release notes. And then just go there and make that change. You know, just put that in there. You know, save it, however you save it. And now if you do something like git status again, some things have changed, right? Now you got to change. Use another, I'm jumping ahead, I'm using things we haven't touched yet, but git diff will show you what's changed. It's all the same thing that you're seeing in Sourcetree with this branch. Although now notice there's another line coming up here, and this is the things that you've done. Right now this is what you've done that you haven't committed yet. So.
Wait, I'm sorry. Could you go back to VS Code? I clicked away for a second. Did you edit the?
Yeah, I just added. I basically looked at what Sourcetree said down here for this change, and then I just went ahead and made the same change in that file. That's like that tags.html that's down here. I'm like, oh, this is in the mild directory, that's in my repo, right? A directory in my repo. And it looks like this thing has this change in it. Let me do the same thing in my code base, right? Because this is all this stuff you're seeing in Sourcetree to this point has already been committed to Git. And now we're gonna go off into the wilderness and make our own commits, which is what we're starting to do here. And so Sourcetree is reflecting now what we're doing. And notice it shows our changes just fine as well that haven't been committed yet. All right, so you can see this is the same thing. If I go back, I'll prove that it's our changes and not committed changes. It could be something like that. And that's our changes here. That's my changes. And that's all still local. We haven't pushed anything. We've not shared anything. This is all yours in your repo on your hard disk. And we've not actually put it into Git yet, this change. Right, that's why it says uncommitted changes up here. So we can say, let's see, where we at? We haven't committed anything. We could do, have you guys used Git at all already in your class? Am I covering?
Yes,
totally
sir.
Yes.
Okay. So you know about Git add. You can do a Git add and kind of look and see what happens on Sourcetree. Okay, so not a whole lot, but now they're staged, right? Before they weren't staged, they were down here, but now they're in staged, which we'll talk about as well. And then you can do a Git commit. Here we go. Oops, doesn't like bash does not like bangs. It means something special to it. So let's not emote. Okay, so and there now it has a commit associated with it. If you've done a Git commit. So yeah, I'll go over unpacking objects. It's not important as far as what we're doing here at all, really. But when we start to look at the plumbing of Git, then it allows us to see where those objects are in our repository. So let's take about a 10-minute break. Maybe come back at 2, and we'll start to dig into the plumbing behind Git a little bit. Anybody, any questions before we break?
Chris, I have a question.
Sure.
I tried to push my change to the HTML file, and I got, please make sure you have correct access rights.
What do you mean when you say publish?
No, I tried to push, and that's what I got.
To push, okay. Then did your team lead have give you right collaboration access?
So he's gonna have to add me on his GitHub?
Yes.
Okay, got it.
Yeah, he'll have to add you. Because it's public, you can see and Git pull or Git clone, but to Git push, you have to have access from him. So yeah, definitely the project team leads it. Make sure you add your collaborators in order for them to push back, and realize that that means they can make changes to your repo without asking. So there are other social media constructs in GitHub that do allow you to manage that kind of access. Things like pull requests and pull reviews and comments and branch protections and all. We're not going to cover any of that, right? We're just going to go straight Git clone, Git push, Git pull. And that's just Git, and that actually underlies all those other things as well. But
kind of piggybacking off of Guillermo's question, so I also just tried to push, and I got the authenticity of host GitHub can't be established. Are you sure you want to continue? Is that just like a generic warning, or
host GitHub? Is it GitHub or GitHub.com?
GitHub.com.
Okay, that sounds like something with maybe your SSL certificates. But yeah, if it lets you continue, then go right ahead. I feel pretty confident about GitHub.com being a real thing.
It says permanently added GitHub to the list of known hosts. Git at github.com, permission denied, public key. Cannot read from remote repository. Make sure you have the correct access rights in the repository that exists.
So you chose, when you clone, you chose SSH protocol instead of HTTPS, I'm guessing, because otherwise if you did a Git Remote -v, you would see HTTPS/:/github.com here, but you're seeing Git at github.com. So you could either add your SSH keys, which is an option if you want to go that route, or you could just change your remote. So let me just do that. You can use the Git Remote command to do that. So Git Remote RM for remove origin. Now it says I don't have anything here now. And now I can do a Git Remote Add origin, and then put whatever the right one is. So you go back to your, where's my GitHub? Go back and get it. Only now, if you're on code here, make sure you don't click SSH, but click HTTPS, and then copy that, and then paste that over here. The other alternative is to just blow away your entire repo and start over, and then make sure you click HTTPS here under the clone options. Not sure what even GitHub CLI is, yeah. But HTTPS is, unless you know SSH.
That's strange, because I'm looking at it now. I went back and I cloned HTTPS.
Okay. What does Git Remote -v tell you?
So I just did the remote add origin and added the HTTPS again, and yeah, now it's HTTPS. So
okay.
I guess I did. I don't know.
Maybe it's easy to, if you've clicked on SSH before, GitHub remembers that, and it's not always really obvious. They've actually added the red underlines recently, because before it was just bold, which is horrible UI wise. But Now it's a little more clear, but still a little nuanced. So yeah, you have to double check you got the right protocol or the one that works for your situation.
Thank you.
Cool. All right. So any more questions? Otherwise,
yeah, I have a clarifying question.
Sure.
So I know for the mild path, right? When you click on mild hello world, it shows you the tags.html in the mild folder.
in Sourcetree or
Yeah, on Sourcetree, correct.
Yep.
And then
Okay.
if we do the non-mild path, it shows the .py files. So that's going to be like the difference, right? Do we just follow the .py stuff that's showed in the display window?
for the spicy, yes.
Okay.
Yeah,
Just wanted to make sure
the
I was-
spicy is all the anything non-mild. I thought about going back and like renaming all the branches, but I was running out of time. So next class will get that. But yeah, if it's not mild, then it's spicy. Good question. Thank you. All right, so yeah, go ahead and try checking some stuff in. I'll be back in about 10 minutes, and we'll take a closer look at kind of what some of these things mean on this on the source tree view, and then how it maps out in your GitHub repo as well.
I'm a little unclear. What are we doing?
I think we're just taking a little break right now.
Yeah, just a 10-minute break.
Okay, sorry. I thought we were going to breakout rooms to do something. So
Actually, from what it looks like, we might be going to breakout rooms. Or at least that's what it looks like everyone else is doing.
okay.
I took it as a break, not as a break to work on something, but a break
Yeah,
to
we're
actually
taking a break.
Okay.
Coming back. He's coming back with more lecture in 10 minutes.
All right, I'm good.
Oh shit.
Did anybody set up this this plugin that's in VS Code for reviewing stuff? And do you want to jump in a breakout room to walk me through like the initial setup?
Sure. Yeah. Yeah, I just did the one that Jason posted.
Yeah. I love keeping everything in VS Code if I can. So that's what I was.
Yeah, no, it's pretty cool. Actually, if you just go to the extension store, I'm pretty sure there should just be called Git Graph.
Yeah, I got the extension. I just don't know how to do all the link and all that.
Just on the bottom. Do the what?
like how to link it over to the GitHub and then basically get into the Explorer on it and stuff.
Oh, you don't have to do anything. Just on the bottom of your little bar, just click on Git Graph.
Oh, that's super easy.
Wait, Jordan, are we supposed to fork?
From what I understand, we're not supposed to fork it because we're supposed to be working like as collaborators, so we can actually be able to push directly to the same branch while having to like send a pull request.
Wait, Jason, could you say that again?
So the way I interpret it is that we send the invites so that we can actually push without having to send like a pull request. So it's like we actually have the permission to push to the actual branch that we're working in. So we don't need to fork it.
There should be one person on your team that forked, and then you all clone off of that one person.
Yeah.
And then you don't fork from there. We're gonna be using branches from them.
Correct. The only thing that I don't get, I guess, because I'm not too familiar with it, how come all of the stuff we're doing isn't overriding what like the other team members are doing? Is that because of the branches?
Branches.
Are they actually pushing though? Because I mean, they can push to the master branch. That should make changes.
Wait, so you guys aren't working on the master branch? You're making your own branches, so you guys don't like overwrite each other's work?
I think like over the course of the exercise, that's what we're gonna do. But like right now, we haven't. We just followed the setup.
Do you think we're all just like super smart, and since we're doing baby steps, we all think we're lost?
Yeah, that's what it feels like.
Definitely not, because I forked out.
I never assume I'm super smart.
Just so I'm following here, so our team leader, they fork it, and then we just clone from their repo. But are you guys saying that we should then we should branch immediately? Or I might have missed that part. That's where I'm a little confused. Like, has anybody branched yet?
No, I don't think, well, other than doing the setup instructions, I don't think we're setting anything up like that yet. But I'm assuming over the course of this thing, we're probably gonna mess with it, but I don't think you have to do that yet.
Okay, cool. Yeah, I missed like the first 10 minutes. I feel like totally like a little confused, but I'll thank you. I appreciate it.
Hey, Chris, real quick. So our team kind of misinterpreted it, and we accidentally forked from the invite. So is there a way do we just need to start over and then just copy the code from his invite?
Yeah, so the invite that you're talking about the email you got, or?
Correct.
Okay, yeah, that probably includes a URL to his repo that he forked from my original repo. So yeah, that should point to, like, if it's Seth, then it would point to Seth/tags or something like that, right? And that's the one that your team uses, including Seth. The easiest way, if you haven't done that, yeah, just get rid of the directory, do a clone again with that URL, and then we can work from there. So to kind of review where we came from, we looked at my original repo, Walquis/tags. The team leads should have forked from that repo, just the team leads. And then they could either chat you that URL, or you could, get invited, which you need to get invited anyway in order to push changes up. So either way, you get the URL to your team leads fork, which should have your team lead's name in it somewhere. And that's what you clone down. Because up until you actually clone, nothing comes local. It's all up on GitHub. So far, so good.
And then in addition, are we supposed to be using our own? Are we supposed to be pushing to the main branch, or are we making our own branches?
Yeah, we'll get to that. We haven't actually branched yet. We've looked around at different branches. We haven't actually made any changes on those branches, except like right at the very end, I started to, I did a commit. But unless you change branches, you're going to be on master. So
okay, just want to make sure.
Yeah, sure. Good question. Until you do a Git checkout, and it's something besides master, you're going to default to master. And if you did that yesterday and you come back to the repo, then it's still going to be whatever you did yesterday until you change back to master. So the Git repo itself knows basically what you're pointing to as far as branches are concerned. So if we look, let's see. Let me open something here. Let me share actually before I forget to do that again. So is everybody clear up to that point? Like which repo you should be cloning down?
I am now, thank you.
Okay, and we covered a little bit that, yeah, you have to be sure you choose, let me share screen. Be sure you choose HTTPS. If for some reason you haven't done that, it could have gotten clicked here or been here from a previous exercise. But for our purposes, let's just clone with HTTPS because we just don't have enough time literally to talk about SSH unless you're already familiar with it. Very useful, but we just don't have time to cover the nuances of SSH right now. So that'll get you going here, and then you do a Git clone with that. Again, this should be your team lead's name here for Git login instead of mine. So just a question from my end. When you got the email, was it with an HTTPS URL?
Yes. Yeah.
Okay. Then that should get you going then.
Yeah, I just deleted it and started over, and it's all good. Thank you.
Cool. So what will happen now then? So you have this repo. You're going to have. If I just say code dot with that. Pardon me that I don't know VS Code well. I just don't work in this environment. I did eavesdrop on you guys and got the Git graph plugin. So I agree, that's very cool. So maybe I'll use that from here on. But yeah, so what's a good place to work on next? So this is what I just did. So let's back up a little bit and talk about where we want to get to from the perspective of this class. For that, let me go back to my notes in the in here. So the curriculum. This is the README in the root repo. All this stuff down here below, the Git diff stuff, that's just extra stuff for, doing diffing things. So don't worry too much about that. Browse it at your leisure, but it's not central to what we're up to. What is central is this, what's in the pre-work. So we've done some of this already. Some of this doesn't acknowledge that there's a mild path. So take that into account. The Git clone, choose your own adventure. So this is just all this is just looking around at what's there. That's not actually making any changes. This pre-work is kind of what we've been doing, is getting set up to go. So just, we haven't covered Unix, but we'll do that on kind of as we go along. Where we do want to go, I'm going to go back now to the home page, curriculum introduction. Scroll down past this. So this here, the course in a nutshell. What you should come away with, if you come away with nothing else, is the Git model, data model, which is those 3 objects, which we'll talk about. We'll cover some of that today. And then there's kind of some homework after today that covers the objects, and it covers the other concept, which is these trees, which we've been working with without knowing it. As it says, head, index, and workspace. So when you see stage stuff, when you see files in your directory, when you see commits, those are all in the context of these trees that we'll talk about. So if you're clear on these by the end of tomorrow, then you've made great progress, and you're ahead of like 90% of other people who say they have used Git, right? Because this is the essence of how Git does these magic things that it does. So this is where we're going to go right now, is digging in and looking at what those 3 objects are in terms of what we see in front of us already. That makes sense? So yeah, pre-work, we've talked about. This object and trees handout, that's going to be the homework for between now and the next class. And then the syllabus is kind of the reference for what concepts we should have covered by the end of class. As I said, yeah, this is the 3 objects, 3 trees. So 3 objects. Let's go back to, actually, what does this look like in the Git graph? Let's go there. Yeah. How many people have the Git graph installed, by the way? Is that something everybody's able to do, or should I stick with Sourcetree?
Can we stick with Sourcetree?
Yeah. Let's do that then. For now, I'll stick with Sourcetree because that's what we started with. So, does anybody know, like if we go back down here to where everything starts under this empty mild tags, what is this 0622136 number? What does that represent?
The hash of a tag.
Okay. What does that mean?
I'm guessing either it hashes every file that's been changed or something, and then they hash all that together again, and then they turn that to a commit, and that probably includes the message they put in there too, something like that.
Yeah. Yeah, that's an excellent swing at it. So there is hashing going on, definitely. In fact, it's the short name for that number is SHA, which is Secure Hash Algorithm. So this is a commit SHA, and all these objects are correspond to SHAs. They correspond to hashes of some sort. So what we're going to do now is dig into and demystify what those hashes are. So here we are back down here. There's where's master at? So I just moved master because I made a commit. So I'm going to go back down here, and I'm going to force master back to what I want it to be. So to jump ahead a little bit, here's an example of how I could throw away a commit, right? I don't like this commit. I want to go back where it was before. And the key is finding out where it was before. So that's back down here. So this is total magic at this point. I realize this, but by the end of definitely by the end of tomorrow, you'll understand it completely and maybe get a bit of it today. So what I'm going to do is basically throw away this 6094997 commit and force the master branch back down to where it was before. And we have to have some sort of reference to say where that place is. We can just use that exact number here, 0662136. So don't bother, you don't have to write this down at this point. I'm just getting us to a place where not in a work tree. Did I mistype it? Yes, I did. 622136. Okay. So there I am now. So now master has been forced back down to where it was before. So the reason I did that is to show you more things about this commit. So first, let's see where it lives in the repo. And to do that, we're going to go into where the repo actually is. So here I am. Let me go up to the root because I was in the mild directory. I don't want to be there. So now I'm up in the, let me bring this up a little bit. So now I'm in the root of my repo. I've been doing ls, and we've been seeing things that we see. You know, we see the README, we see the bin directory, the mild directory, a couple other things. But what we haven't seen is where the repo itself is. And to do that, you can see with the -A option to ls. So I said ls, not just ls, but ls-l for long, and then A for all. And that shows me dot files, not just the files that, you know, that I would normally see. So to dive into Linux a little bit, dot is a current directory, dot is a directory above. That's why you can go cd ... and go up a directory. Not 3 dots, 2 dots. Because that's what the directory above is called. It's literally a link to the directory above us. There's also .git, which is a real directory here, or subdirectory. And that is where all of your repo lives. That is your Git repo right there. So let's see what's in .git. We see some things that look a little bit familiar. There's head. So we can actually look directly at head with our cat command. And we see this is how Git knows that we're pointing at master, is that file in that .git directory literally says refs heads master. And so if we were to do a Git checkout something else, this file would change and head would point somewhere else. And as you know, this dot represents where head is on our source tree. But that's how it keeps track of it. If you recall, we also did a bin unpack objects. So if we had not done that, then packed refs would have had a bunch of stuff in it. And it really doesn't have anything in it now. Actually, no, I'm sorry. It would be under, there should be a packed directory. Maybe it just gets rid of it completely if I don't have any objects. So because we unpacked our objects, now our objects directory has basically a bunch of our, all these shells we've been talking about down in here. Yeah, there's the packed directory right at the bottom. So that's where if they were packed, then they would all be here and none of them would be up looking like this. But we've unpacked them so we could see them. So that's what the unpack objects does that we ran before. Again, nothing you have to worry about normally, but we want to see what's going on in our Git repo. So let's go back and look here at master. All right, so 0622136. So is that in here is one question. And the way that Git does things is it takes the first 2 characters, 06, and it uses that for a directory name. And then it uses the rest of those characters for the file name. Now this is actually a lot longer than just what, like 8 characters. The whole SHA is huge. You know, like if we do a git show, let's go back up a moment and do like a git show. No, that's not a, yeah, there it is. So there's our actual commit. So it's not just these 8. It's this whole long 40 character SHA. But we have enough to go with if we just use 8. It's enough to make it unique. So let's go back down here, go back down to objects. So yeah, we said this is the directory. So what's in that directory? ls space 06. And there's the rest of it. That's actually a file. So I think it was you, Kevin, that said it's a hash. So the hash is of that, what's in that file. The hash is of those contents. And we can actually look at that with a kind of a low-level Git command called git cat file. And we can give it, we can actually be anywhere, but we can take the first few characters of this thing. Not just this, because this, remember, is missing the first 2 characters because that's used for the directory. So this isn't the whole SHA, but this is, and also this also is enough for us to go on. So let's see what's in there. So what we just are seeing here is this is the first object type. This is the commit type, the first of 3 objects. Okay, and these are the actual unpacked contents of that exact commit. So tree, parent, author, committer, and comment. Those are what gets hashed and put here, exactly like Kevin was talking about. So when you say git commit, then it goes and it takes a pointer to the rest of the rest of your directory structure, the tree, which we'll talk about more. And then it takes a pointer to the parent, which is how we can find our way back to, to parents, to previous history. So there's that commit. And if you notice, this parent right here is exactly right here. Like this is literally how Sourcetree draws its graph, is with this information. So it traces these commits back and represents them. So 38DC 3D7 is the parent of this 0622136 commit. Continuing on, you've got the author, you've got a timestamp of the author, and you've got a timestamp for the committer. And then an empty line by itself, and then the comment comes last. So that's all completely enough to build this line in Sourcetree to tell you what's going on. And I know that was a lot. So any questions thus far? Does that make sense? That's type number 1 of 3 for what's in your git commit. I mean, that is a git commit. Right, this is the information that is needed in order to constitute a git commit.
Is there a way to look directly at the object without using the git cat file?
The commit object?
Yeah.
I mean, in a sense, that's what we're doing right here, is looking directly at the object. We're just representing it in a graphical way. Like all that information that we see with the cat file is over here, right? The tree is this thing down here. It points to the directories and files that make up that commit. The parent is this thing right here. That was the commit before it. The author is this thing over here. And the date, if you were to take this date, and this is just a Unix representation of the date, is exactly this over here. And there's probably some ways to view the committer separately as well. I just haven't seen. Let's see, off the date labels. Yeah, there's probably somewhere in Sourcetree you can see the committer separately. And then, of course, the comment itself. So, yeah, you never actually use git cat file kind of in normal life. It's because you just don't need to. But we want to see how the things are wired together. So we're using it to kind of poke around a little bit. So,
yeah.
Go ahead.
You know, the folder you took us to, the inside Git, and I was just playing around with that file. Like if you go to the .get objects and then the 06. Go to the actual file. I'm saying, like, if I try to cat that actual file, it's just going to shoot out bits. I'm saying, what is that? What's in that file?
That's the compressed version.
Got it.
So Git cat file does some. There's a compression library that Git uses, and Git cat file uses that library to uncompress it, as well as when you do Git operations, it does that exact same thing. So all these objects are in very compact formats. And so that's why if I say, like, I can literally say, if Unix has a utility called file, which tries to figure out what types of things are. So if I say file 06 / it guesses wrong, actually. It thinks it's a VAX executable file, which is not, of course it's not, but it's definitely not ASCII.
So it's a zero compressed data file? Because that's what I got when I did it.
Yeah, yours is better at it than mine. So yeah, that's more close to what it is. If you go to gitscm.com, there's a whole chapter on unpacking these things. And you can actually write code in Ruby to go and make a legitimate Git commit with a Ruby gzip library, whatever zip it is. So you could build it yourself totally, but it's not necessary to understand what's going on. I actually tried a class to do that and lost everybody immediately. So go to git-scm.com and you can get as deep as you want in that. I think it's like chapter 7, or something in there. But I think it is important to know how these things are wired together, because we're going to be walking through different aspects of these objects and working with them. So for instance, the second object is the tree, right? And that's another SHA. So let's look at that. We can use git cat file to look at that as well. -p is just print. You can do a -t to see the type. Even though we already know the type, we can still, it just tells us that it's a tree. But if we say -p, then it prints the contents of that thing. And we only need the first, few characters, maybe even the first 4 is enough. Okay, so there's the contents of a tree. So of course it's a different data structure. It's a tree, not a commit. But the graph is constructed of not just commits, but also trees. And so it basically corresponds, as you can kind of see here, to either a file, like we have a .git ignore file. If we were to scroll up a little bit where we did the ls-la, we looked at .git, but there's also a .git ignore file here. So that's there. There's read. So this is basically everything we saw in our ls. Right, this is a representation of our workspace. Only it's a committed representation because it's a commit that points to it. So that's it's got permissions. This is how this is a representation of who can read and write to it and whether it's executable. So that's a Unix kind of thing. And the name. And then here you've got whether, if you notice this column here, which says blob and tree, it's recursive, so you can have another tree. So it could be another subdirectory, which that's what we saw. Bin is another subdirectory. So by definition, a subdirectory is going to, a tree is going to resolve into a subdirectory when you check it out. So that's type 2, right? We've got the commit, we've got the tree, which are directories, or like structures, we could say. And then finally, at this points, we're almost at the end. Hang in there. This is type 3 is the actual content of a file, and they call that a blob. So if we look at something we're familiar with, let's see, are we familiar with anything in here? Probably the README. That's going to be a little large. Let's look at the .git ignore. Anybody familiar with the .git ignore file? You know what that does?
Yeah, you specify which files you want to ignore when you're adding to your repository.
Yeah. So it's, either directories or files or star this or that. So we can actually look at this compressed version with git cat file, cat-file, and select the first few characters of this guy. And oh yeah, that looks kind of familiar, right? There's the actual contents. So Git stores content, actual file content in blob. That's the third type of Git object. So that's getting in the weeds, I know, quite a bit. But if you grasp that these objects kind of they construct this graph, right? And they can be arbitrarily complex or simple, because trees can have more trees in them. So you'd have subdirectories. Commits point to parents. So you've got basically what you see here is a commit that points to a tree. So this mild directory here is represented by this tree that points to the mild directory. And then inside that tree is a tags.html. So if we were to, again, just kind of dig our way through at a low level, we could confirm that to ourselves by doing a cat file on that SHA. Sure enough, there's one file in here, tags.html. And I'll bet if we did a cat file with this blob, we would see this content right here that we're seeing in Sourcetree. Let's take a couple of breaths. So that is the essence of the Git data model. Now it looks complex because you've got all these long, gobbledygooky looking SHAs, but they're basically just unique addresses for content. Now here's another, the big idea is that, I think as Kevin mentioned, these hashes are produced from the content. So like, if you were to apply the Git algorithm for hashing to tags, if the content changes, then the hash changes. Okay, I'll say it again. If the content changes, then the hash changes. And furthermore, if it has this same hash, you can bet that it's got the same content. So that means that Git can do a lot of compressing and a lot of optimizing of the way that it stores things because of this property of hashes. Now I can't go and reconstitute the content from a hash. That's like it's a one-way thing. But I can tell, if two things have the same address, like this is what a hash is, it's an address. If they have the same address, they're the same content. Guarantee it. So if we go back here to our master branch, let's experiment with this a little bit. So say I go make a change, and feel free to follow along and do this. You know, go to tags.html and, you know, put in a change. It has 3 objects in its data model. So some kind of change. Okay. Save that. Now I'm way down on the weeds here, so I need to go up a couple levels. Up out of .git, cd .. goes up a directory in Linux. And now I should be at the root of my repo, kind of back on land here. So if I do a git status, I should now see that there's something that's been changed. Okay. So we know to say git add. I can use either the whole path, or I can just say dot and it adds everything that's, you know, that's in there that may be changed. And I'll do a git commit. Okay. My chat longer. So Jason says, is it possible for 2 files to have different contents, same hash? No. Well, I mean, yeah, so yeah, there's a chance in the universe that it could happen. And in fact, like last year or sometime, somebody saw a case, which is why secure hash algorithm is not as secure as it was thought to be when it first came up. But for our purposes, it's, you know, it's good enough. There's, you know, there are projects to put a more secure SHA algorithm underneath Git, but that's a huge undertaking. So I don't know where that's at. I think it'll be a while before that would actually happen. So, and we're not actually using, like, it's not actual security. This is just for us to address content. So we don't really have to worry about, you know, the security implications of hash collisions, if that makes sense. So as long as it's unique enough, right? Nobody's going to get fired because of a hash collision in Git. Pointing to 2 different things. So let's go back here then. I encourage you to follow this along. Your SHA is going to be different. Why is that? If you do a commit,
We're going to have different content in the files, which is going to cause the hash to change.
Okay. What if you typed exactly what I typed in here?
Wasn't the hash based on our username too?
It should be the same, shouldn't it?
Well, so the content will be the same, right? But yes, the username will be different for one. What if the username was the same? Would the commit be the same SHA?
I'm going to say yes. Yesterday, I was messing around with MD5 sum, and somebody on a different computer had a text file that had hello world in it, and I had it, and we had the exact same SHA, or the exact same hash.
Right. And that's how Git behaves as well. Let me point you back to what the actual content of the commit is. Where was that at? When we did it, our very first, okay, right here, git cat file -p. So what is the so assume I had the same content, I had the same comment, and I was the same user. Would it be the same?
No, because the time would be different unless you committed at the same time. Is that
time? Exactly. Yeah, in order for it to be the same, you have to have, like, this content would have to be the same, right? You have to have the same subdirectory, the same parent, which we do, that we can do that part. Same author is doable. But yeah, this would be really hard to get the exact same timestamp in there. That'd be the hardest part, actually, probably. You know, if you want to really geek out on it, you could try to create a commit with the exact same SHA as some other given commit. I think gitscm.com has the tools that could let you do that, but it would not be trivial. But on the other hand, you know why? Like if you change your comment, you don't, even if you have everything the same, you don't get the same commit SHA. You get a different SHA because now you've got a different comment. Or if you take the same content, sometimes you'll want to do this. You want to take, like a bunch of this stuff, and maybe you want to take these changes here for some reason, like that. Maybe these 3-4 changes here, and take them and put them up on some other branch and just replay them on top of that branch. It's the same stuff, but Git puts totally different commit SHAs on it. And that's because, it has different parents now. And so you can't just reuse 535 for BF8 and put it anywhere else in the tree because it has, now it's got different information in it. So you get a different hash. It represents the exact same code, but it's going to be a different hash because you've got different parentage for one. So that kind of, that threw me for a while because I'm like, why can't I just like see the same thing? It's the same code. It's got the same changes. It should be the same, but not according to Git's data model. It doesn't work in, when you understand what Git is doing with these SHAs. So, three object types. Anybody want to see if they can repeat those back to me?
Actually, yeah, now that we're talking about that, I was really hoping you kind of clarify some things about that. What I was really confused is we're talking about, I guess, all of that was a commit, but then we also, I just don't understand how they're related. Are they all the same parts of the same thing? Or are they 3 separate things?
There's three separate things. Now that I've talked about all that, let me go back and review. That would be very useful. So the commit is the thing that actually goes into like the repo. Okay, like we can make changes, we can type, we can git add, we can do all this stuff. Until we do a git commit, it doesn't turn into a commit. So when I say, when I'm looking here, the thing I'm looking at, this 0622, if it shows up here in Sourcetree, it's a commit. Like that's the only SHA that shows up in Sourcetree here as a SHA. There's other SHAs under the hood, right? Here's one that's under the hood, right? That's tree SHA. So there's a commit SHA, tree SHA, and blob SHA, right? They're all SHAs. They all hash content into these SHAs, but the content they hash is of different types. So there's like file content, which is the blob. There's the directory structure content, which is the tree, like which has, as you see kind of down here, like the tree has permissions and like things that hang off of it, other files and other directories, and then it also has the name of the file. So the actual file itself, if we cat that blob, there's no Git Ignore in that. When we cat the blob, the Git Ignore is something outside of the blob type. Like the blob doesn't carry the name of the file with it. It's just the content. The file name is up in the tree type, right? The file names are up here.
Could you clarify a little more about what the tree and blob is?
So yeah, sure. So tree is like a directory structure. It's the rough equivalent of what you see when you do an LS, right? So it's like the whole, like if I'm in the tags repo here, I do an LS, I'll do an ls-l to show the types. So in Linux, like the README is a file, you can see that because it has a dash here instead of a D. If it's a D, it's a directory. When you're using the -L option on LS. we're not in Git at the moment at all. This is just Linux, right? So you have files and you have directories, and you have these are also permissions, which is roughly the same as what we saw in Git. These DWRXs, the WRXs are permission notations. I won't get into those right now, but it's basically who can read, who can write, who can execute. So this is a tree, right? If we do an ls, we can do an ls -lr for recursive, ls space -lr. But now we get a lot of output, which is basically the whole structure. So here's the top level. Here's the contents of bin. Here's the contents of config, so on and so forth. Just what you would see in your Finder, in other words. If you were to expand your, if I were to navigate down here and let's see, I can do this in here. Source CP tags. So if I go to my Finder, right, and I choose this list view here, and I expand everything. Like this is a tree. This is the tree here, right? This is what. So if I look here and let me go back up to that tree list that I did, that cat file of the tree. So this was the tree of the top level. So here's, let's see. It's not showing Git Ignore because my Finder isn't set well, but it is showing bin. Right, here's bin. And bin is another tree because it's a directory. So the whole, the whole tree type is showing trees and other files with the permissions attached and the names attached and the content ultimately attached. If it's a file and not another tree. And the file, the content is going to be a blob. That's the last type. That's like the leaf node of this whole representation, this whole graph.
So does a commit contains trees and blobs? Is that accurate?
Exactly.
Oh, okay.
Exactly.
Okay, thank you.
Yeah, every commit is going to have at least one tree, and actually really only one tree, I think. You'll probably be proven wrong on that, but yeah, here we are. So, excuse me. Every commit has a tree. It can have one or more parents. Now, when would it have more than one parent? Anybody got a handle on that? When would a commit have more than one parent?
With have collaborators?
A merge branch.
A merge. Yeah. Yeah, if you merge from another branch, then you've got two parents. You see that on the graph then. So you'll have two of these on a merge commit. So and you can have actually any number of parents, which is crazy, but it's true. I don't go there, but you can. So and of course you have author committer. So notice that trees do not have author committers. That's not what a tree is for. A tree is for representing directory hierarchy. And then the blob is purely for representing the content of a file. So, and they all get done with hashes. If you put a file in, you hash that file content and you get a blob SHA. You you commit a directory. You take the trees that make up the directory and the blobs, and you hash that, and then you get a tree SHA. And then when you're ready to go into Git, you do a Git commit of all that, and it takes that tree, and it takes the parent, and it takes you, and it takes your comment, and it hashes that all into a commit SHA, and it goes in as as part of that graph that you see in Sourcetree. And that's something you could push up to GitHub. And so when you do a Git push, then it has this graph now of all these trees, blobs, and parent commits, and it throws that all up there, and everything that's attached to it, kind of like a bunch of grapes, anything that's relevant to that commit, it just traces on down and pushes that whole thing up there. And then it becomes visible to your team. But the cool thing is it only pushes what it needs, because it just traces down through that bunch of grapes and takes those, and that's all it has to go. So that's a lot, but as far as the model goes, that's pretty much it. Everything that Git or GitHub does is around this model. It's around these three types of blobs. So I'm sorry, these three types of SHAs: commit, tree, and blob SHAs. Everything you see is made up of these three types. There's another one called tags, which is kind of a variation, but that's not something we really have to worry about to understand Git. So when you're looking at stuff here, you're looking at commits that are tied to trees, and these trees contain more trees, or they contain blobs, which are the file contents. And so Git is this like simple data model with this huge cloud of complex commands that do magical things to these commits, trees, and blobs. But that's all they are. They're all commits, trees, and blobs. So, gosh, that was a long session. Let's pull back a little bit and take a break. But let me give you these commands to run. So I'll just chat them into the. So let me chat in there. So if you haven't done this already, go into your .git directory. Go into the objects, and then looking at your source tree. Actually, you know what? You don't even have to do that. You can just do it straight from where you're at. Like, you don't have to go into the Git directory at all. I want you to use Git cat file to see each of those types of objects from something in Sourcetree that you recognize. Like, for example, if you want to look at, look here, you can do that. If you want to look at, one of these others, you can choose that. Like, for instance, start with the 4C9B6A, B6BA. Do a git cat file -p. So on 4C9B should be enough. And then pick out what's going on, right? See if you can recognize each of these from what's in Sourcetree, and then dig on into the tree itself and see if you can recognize what's in there based on what you see in Sourcetree. So for instance, git cat file, cat-file, space -p, and then just pick off the first few characters of that SHA, and then see if you can recognize what you're seeing based on the output of the contents of that tree. And then the same for a blob. So take a commit and trace your way all the way down to a blob and see if that makes sense to you, what you're seeing. And if it reconciles with what you're observing in either your Git graph on a VS Code or your Sourcetree graph. If you want to just go right on up to the sample solution, that's got plenty of changes you can work with as well. Plenty of content. And we'll reconvene in about 10 minutes. Any questions before that?
Are parents trees of commits, or are they just other commits?
Parents are always other commits, by definition. Yeah, good question. Yeah, if you see it in Sourcetree, then it's a commit SHA. No other SHAs show up in Sourcetree, even though that's what's used under the hood. So if you see this number here, it's always going to be in a column called commit. You know, if you see this SHA, it's visible in Sourcetree, and really here in the command line as well. Unless you use like git cat file and these other sort of weird commands, normally you don't use those. Normally you don't see the tree or the blob SHAs anywhere. What you see are, like if I do a, what's an example? A git branch. That doesn't show anything, I don't think. But if I do like a git show, the thing I see is going to be a commit. If I do like, this is kind of a bit of an exception here, but it's basically a commit in progress, the index. We'll go into that next session. But you're not seeing a tree, you're not seeing a blob SHA. Normally the SHAs you work with are going to all be commit SHAs, but it's important to know under the hood, I think, that this is what's going on. These are how these things are wired together, and how Sourcetree, for instance, can show you what it shows you. See these three data types that are under the hood. So we'll come back in a few minutes and play with it some more and get some changes going in our repositories. All right. Home stretch for today. How did that go for folks? Any questions, comments? Able to trace your way down from a commit to a tree to a blob?
I guess I kind of had one. We're looking at that cat file. I'm sorry, I keep asking questions. Maybe I'm just not clicking for me. But
sure.
Like I did a git cat file on what's the checkout about page, and there's all kinds of files in that. Like when I did the ls, I can see a whole bunch of stuff. But in the cat file, whatever that's called, the file that I'm printing out through Git, I only see a tree and a parent and no files.
Okay. Do you want to share your screen? We can walk through it. Okay, so in the about page. Okay, and the git cat file on the commit itself. Okay. So commit, yeah. So you're wondering why there's only one tree, even though there's like several directories there? Is that the question?
You're on mute.
Yes, sorry, that was my question.
Yeah. So good question. So if you think about like the root of your workspace, like there's every set of trees ultimately lives under one tree, and that's your workspace root, right? So all that the commit needs to know is the root of your workspace, because then all the other subdirectories live under that one tree. So in your case, like do a git cat file -p where you're at of 4030. That's your tree SHA, right? So cat file that. So there's the rest of your trees.
Okay, I get it now. Thank you. That was it. That's it. Thank you.
Yeah, the tree you see in the commit is the root of your workspace that everything else lives under.
Okay, now I think I get it now. It just clicked for me.
Cool. Great question. Any others before we move on? So one more thing I want to cover today. I want us to start getting some exercise and putting things into Git and pushing them up and seeing what happens. As we do that, we're going to look at this. We're going to work with this other concept and hopefully understand it as we work with it a bit. And that is those, I'm going to use this word and it's going to be confusing, but these trees. So trees here means a different thing than trees over there did. Okay, it's an overloaded term. Sorry about that, but that's what they call them. I guess very useful term. That's why it's overloaded. But anyway, so as I mentioned with Tynan just now, the one tree at the top of your workspace is all that a commit needs in order to have what it needs, right? And so what we're going to look at now is kind of three sets of those. There's three different kinds of trees that Git uses in order to organize our changes and move them on in out to where they can be shared and collaborated with. So to introduce that, let me go back to our Git repo. Let me share my screen because I keep forgetting that. Here we go. So I mentioned the objects and trees handout. We've been touching on pieces of that all the way along here, especially this part, the three objects. So what now we're going to do is we're going to touch on that second part, the tree part. But I still want you to please, if you can, possibly make time between now and tomorrow go through the whole handout and review that material. Work through it if possible, but at least review it. But we're going to touch on it right now, and then we're going to do some work with Git itself before we close out the session. So objects and trees. So here we go. Skip. Git versus GitHub. I touched on that a little bit, but there's a graph that tells you what's Git and what's GitHub, or not a graph, a table. What's Git and what's GitHub. Stuff on the left is Git, stuff on the right is GitHub, which also uses the word repo, but doesn't use clone, it uses the word fork. So if you hear fork, that's GitHub thing. And also anything to do with organizations, teams, collaborators, permissions, style stuff. Skip. We did this, a lot of this. Work through it, look through it at least. Git objects, skip. Some good stuff here. Okay, now we're down to this thing I want to cover. So, trees. Here we are. Did I get back to where it was? No. What did I just do? Okay, here's not the same tab, but it'll work. All right, so when we made a change, I think you guys got to do this today. So let's see where we're at here. First, what directory? Okay, we're top of the workspace. And what branch are we on? Git branch, master branch. Can jump back to Sourcetree, kind of see where we're at. So I've made a change actually. So I've committed this thing. So how did I get from there to here? So let's back up again. I'm going to do that magic thing I did. Reset, I think it was called. Yeah, so I'm going to reset things back to where they were. So here I am back down here on our 0622 SHA, where everything starts. So now I'm going to do the same thing, but I'm going to walk through which trees we're on. Okay. So right now, what I'm looking at is my workspace. And everything you do in Git, these trees are in some relationship to each other. So for instance, if I do a Git status, let's do a Git status. Let me clear my screen. You can use Command K in Mac OS, by the way, to do this. Just to get things out of the way. So it says I'm on branch master. I knew that already. It says I have nothing to commit. What does that mean? Nothing to commit. Anybody have a?
It means that you haven't made any changes to any of your files.
Say again, Jason.
It means that you haven't made any changes to any of your files since the last commit.
Okay. And it says working tree clean. What does that mean? Kind of the same thing. It sounds similar, right? Nothing to commit, and your working tree is clean. So what it's actually saying is something about your index and something about your workspace. So it's actually commenting on 3 trees here. The first one is, it says this is where your head is pointing. Okay. This one says this is what your index state is, and this says this is what your workspace state is. So for instance, if I were to make a change in my Visual Studio Code, the same change I always make, put something in the body. Right, here we are. Okay, now what happens? What's Git status going to show me now? Any guesses?
Would it be like unstaged changes?
Exactly. Change is not staged for commit. So what is the state then of the three trees now? The head, the index, and my workspace. What does that tell me about the relative state of those trees?
So it's only the workspace is changed. The index and head should still be the same.
Exactly. Yeah, that's why notice change is not staged. So there's nothing staged, otherwise it would tell me about that. So what if I do a git add? Oops. Git add dot. What's gonna show up now for git status?
It's going to say that your changes are committed or ready to commit.
Ready to commit, exactly. So which of the trees has changed? Which tree got changed by a git add?
The index?
Yeah. Any others? No. Yeah, no other trees got changed. Right. So I basically had head, index, and then my modified, and now I've just moved the index up to be the same as my modified, the same as my workspace. So now there's no more red showing because index and workspace are the same. However, head and index are now different. So now there is something ready to be committed, unlike previously, because now it's staged in the index. So you can see how the change makes its way from your workspace to the index to eventually to the head. And how does it make its way to the head?
Like committed.
Committed, yeah. So which tree changed then?
The head.
Yeah, just the head. So now our trees are all in sync again, but now they've all moved up to what is now a commit because we just did a git commit. Right, so of course you can see that here. So here's the thing, what if we wanted to go backward? Can you imagine a situation where you might want to maybe not throw the commit away, but maybe just change it a little bit? When might that be something that you would want to do?
You have completely messed up your current project that you're working on, and you need to go back to something that actually works.
Okay. A frequent occurrence, yes. So so then enter reset, right? The one I used before that was magic. So let's skip down a little bit. This is a useful graph, but I won't worry about this right now. We've basically covered it. But moving changes the other way. So there's this command called reset, which is arbitrarily complex, but we're only going to touch on like 3 things that it does. And these 3 things are basically moving changes back and forth, well, back in these trees. So it's basically, we're going to do the opposite of what we did with the add and commit. Okay. So here's our trees: head, index, workspace. We've moved them all forward, 1 commit. And now we want to only move the head back and leave index and workspace the same. So that's where these different options come in for reset. So soft only moves 1. Kind of, you think of your workspace as where you're at and the head as being the furthest out. It only moves the furthest out 1 back. So let's try that. So git reset -- soft. And now we have to tell it where we want it to move because it doesn't assume that we want to go 1 back. It'll move it anywhere or try to. So there's a couple ways we can do that. We can look at Sourcetree and we could say, well, let's see, this parent of this commit is pointing down, 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 down. The parent is this guy. So we could go ahead and just say, 0622. So I'll go ahead and do that just as a, okay. Now what's Git status going to show me, do you think?
Should show you right before you commit.
Yeah, exactly what it did up here, right? Because I just moved head the other way from when I committed. So I can, so I can do the same thing. I can go commit again. Now, here's an example of when that might be handy. What if you had, 99 files that you wanted to commit, and you committed them all, and they were good and they're lovely, but then you forgot one file, and you want that one added in too, right? So you could either back all the way up, and do it all over again, or you could leave all those 99 in the index, just like we did here, and then add another one, right? I could say I have, I'll just choose a random file here, which won't make any sense code-wise. Actually, let me not use BI. Sorry, let me do it the right way and use VS Code. So say I want to put another, some more changes here. All right, there it goes. Now, if I do a git status, what shows up? So that's what I had before, but now there's this guy. So all I have to do to include them is to just add them. Right, now I do another git status to see where I'm at. I do a lot of those git statuses. And now they're all on the index. And then I can just up arrow and find my commit again. So now I've been able to add more stuff to my commit without having to throw the whole thing away and start from, remodifying my files. I just had this one small change I wanted to make. So that's an example of why you might want to move backward. You can also move further back, right? If I wanted to get everything, not just, into the index, but all the way, just, start my index over. Sorry, where was I at here? So -- soft just changed my head, left my index and workspace the same. The next one, which it says is the default. If I don't say -- anything, it just assumes I mean mixed. And all that means is it moves two of them instead of one. So Git Reset, I'll go ahead and say -- mixed. And then again, I have to tell it where I want it to move. So I could go back to my graph again. But it's nicer not to have to do that. So is there something in my commit that tells me what the commit was before mine?
The parent in the top level.
Exactly. We have a way to tell Git to traverse that graph when we're referencing previous commits. And so there is this notation. So we could just say head, and nothing really happened because we're already on head, right? But we could also say thing before head, and that is denoted by this caret sign. And that tells Git, go to the parent, basically. And if we wanted to go 2 back, we could put another caret sign, and so on, or we could just use a number. If we want to go 8 back, so just 1, we'll just go back 1. Okay, so there we are, back 1. So now our changes are uncommitted again. what's Git status going to show us this time? Any guesses? We moved just head back to the last time.
Is it nothing to commit or what?
Yes. Perfect. Exactly right. Because now we've changed head and we've also changed the index. And we've just left alone the workspace. So we backed everything up and now the workspace has changes. They're different from the other two now because we backed those other two up by one. So yeah, so now we can, you know, do whatever we need to do with these and just go forward again. And then the last one is kind of like, okay, this thing is totally wrong. I don't care about it anymore. And we need to throw it all away. So a couple ways you could do it. It gives you some hints here, right? You can do it file by file. And that kind of moves like each file back to what the index is. And you know, that's doable. Or you could set everything to head. And that's the hard option, right? That's this thing. It moves all three to the place that you tell it to go. The head, the index, and the workspace. So, and technically, this is a little nuanced, but it's important. It actually moves the thing that head points to. So what does head point to?
The parent.
No.
No? Okay.
The head caret points to the parent, but head itself points to a reference, a specific reference.
Certain commit.
It points to a commit, yes, but it doesn't point to the exact commit. So let me give you a hint. If I were to look at the file that contains what head points to, remember that .git/head we looked at? Head points to master. So if we watch on here, when we do a reset, so we're going to do a git reset. Now we've already moved back everything except our workspace. So we don't really need to go back to the parent because everything is already where it needs to be except the workspace, right? So we've moved back head. We've already moved back the index. So we just need to make the workspace match head. So all that to say, we want to make it all look like head. So we can just say head, and then it all gets hard reset to head. Now what is git status going to say? Oops, sorry, I didn't do hard, did I? Here's hard. Now what's git status going to say?
No changes?
Right. Right. So we basically blew away these changes because we made it all go back to this place that head is pointing.
That's a question.
Sure.
Like big picture wise, say I made 99 changes, but I forgot one. What is bad about just making another commit for that one last change? Is that
Sure.
because it's just better practice to go in reverse and make sure that last commit was what you originally intended?
Yeah, I mean, somebody is probably going to look back at your code in a collaborative setting and look back at your commits and to try to understand what's going on. So, if you've got a big break, like a big set of changes, you want to have a change set, not a change kind of, gaggle geese sort of set of changes, if possible. Sometimes it's not, but like this thing is hard enough to read as it is, this graph. So yeah, it kind of philosophically, you want to make your graph as understandable as possible. And we'll look at some things tomorrow there where you can actually check in changes, locally as much as you want. And then at the end, you can squash them all down where they amount to the exact same thing, but it's a really nicely packaged, nicely worded commit. But you still manage to like keep yourself at a known good place all the way along by committing your changes. So that's also helpful, just say, okay, it works right now. I'm going to try something else, but let me make myself a checkpoint commit so I can get back there if I screw it up. That's very handy. You do that a lot, to make progress quickly. So yeah, you can do both, and that's where I think I'll sort of leave it off here, as far as the lecture part. But you want to get to a point where Git has your back, where you feel like Git is your ally, not your enemy, and that's a big step to get there. Took me years, but when I did, it was huge because I could do these things and know that I kind of knew where I was in the matrix and make my way back to somewhere that I understood, no matter how far off track I got with my different commits or whatnot. Like Git Reset, I can move my branch to anywhere I want to, and know what I'm doing, right? Know what that means. So I can literally take my, like I'm on master right now, so I can take my branch and, if I think my master branch for whatever reason ought to be up here, at this place, I just tell it that's where I want it to be, and then it just moves. There it is. That's my master. So there's incredible flexibility and power, but this understanding of, on the one hand, what objects you're moving around and which ones you're not, and then on the other hand, how these trees interact when you're making changes, and what's available to you is really key as well. And then you can take a lot of shortcuts once you know that. So let's take a risk here. Let's go for a few minutes. It's about 3:20, 3:30. How about you guys just take some project work and try to make a couple of these changes in parallel and push them on up. Like the only thing missing, that I just did here was I didn't push anything up. Actually, where's that? 622062221. Let me get back where I was here. All right, goof myself up. So if I made changes and I had them change up here, then the next step would be to do a Git push, right? And then your whole team will see it because it'll be up there. And then on correspondingly, if your team wants to bring it down, they do a Git pull, and then it comes down and joins you. So let's try that for 20 minutes. Like what I would suggest is you guys decide who wants to do a change that looks like the hello world. Who wants to try it? Because these changes can be orthogonal. They don't have to be sequential, right? You can do them in parallel. But you're going to find some, I think you're going to find some merge conflicts as all the same. But yeah, take a couple 5 minutes and divvy up the changes and make them locally, and then try Git pushing them up and seeing what happens. And then we can talk about that a little bit. If you want a hint about what will happen, let me find that location here. Somewhere I have a suggested workflow. Back up a little bit. I'll show you that, and then that will give you a hint for what we'll kind of be focusing on next time. Working on pre-work. We did all that. That was working through. I think might be the objects and trees handout. Or maybe this, sorry, I've three objects, three trees. There is a suggested workflow here somewhere.
I think it's on your tags. If you just go down below.
Just on tags?
Yeah, it's underneath your comic, about 4 sections.
Oh, okay.
The walquis.github.io/tags.
/tags, okay. Oh, up here. Course layouts. Roles. Yeah, there we go. Thank you very much. That's what I was looking for. So yeah, refer to this. This will probably give you some hints for how to handle, you know, when your Git push fails, for instance. But take a few minutes and just try to make some changes locally, and you know that I mean, you could use the ones that are here. You don't have to. These are just suggested changes. You could make up your own changes. If you think you know want to add some style or something, or you know, and push your changes on up, do that. But make some kind of change locally and in parallel, and try pushing them up, and then see how far you get with resolving the issues that come up with that. And you know, this can give some hints, and then we'll just take it just a few minutes, maybe like 3:50, to sort of clean up and get pointed toward tomorrow morning. And I'll stay around while you do that if you want to ask questions or get some guidance of any kind.
Chris, I actually have a question for you right now.
Sure.
I went ahead and did the reset head thing, but then it put me behind, I guess, the original commit because I didn't get as far as you. So then, you know, I was attempting to fix it. I think I fixed it, but now within my source tree, within the GUI, it shows a blue line, a red line, same as you, but then an orangish line and a green line. Is that going to affect what I'm doing with my team?
Do you mind sharing your screen? I don't know offhand if that will or not.
Okay.
I'm going to stop mine. There you go.
Let me, so here.
Okay.
And then, yeah, I was running into a bunch of stuff, and I believe you know, like I said, I believe I corrected it because I'm able to now like commit and push again, which I wasn't able to during this whole thing, but you know.
Okay.
I'm not quite.
You are. Okay, there you are. Well, first commit. So you did a merge. Go scroll up again. Let's see what you got up there.
Let me make this a little.
Okay. So are you doing the spicy or mild?
Right now, I'm just trying to absorb information, but I am on the spicy team.
Okay. So, all right. So you got your commits. You've merged from. It looks like. Let's see. Let's scroll down. Let's see where the red comes from. Empty mild tag. So you merged from there. That could be okay because the yellow that looks like the spicy branch. So basically, what you merged from is also on the spicy branch. So you should be okay. If you you know want to use that as some of your changes, you haven't made any commits that are, you know, non-spicy, I guess is one way to put it.
Okay.
So, and again, those branches are just reference points for the kind of like don't just use the branches and merge them in, although you could, but just look at them. Look at the kind of changes they represent. You know, you use Sourcetree to see the changes.
Okay.
And you know, the easiest way to pull them over often is just to do a git merge, but on the other hand, you're going to get a bunch of changes, not just one, if you do that, because notice how the changes are all on the same, basically on the same line. So like if you merged over sample solution, you get all the changes at once and you'd be all done, which would be kind of, you know, beside the point. So look at the changes and, make the changes that are indicated when you select a single line on your source tree is kind of, whether you're spicy or mild, that's the idea is to make each of you make just those individual changes and then try collaborating and getting them back all in the same place when you do a push up to your team leads. So we're sort of implying that you rendezvous on the master branch at your team leads. You can.
Oh, actually, that's another question. Everyone copied my code. I was the one who forked, so that's not going to mess them up either, right? It's the same deal we were discussing.
No, I mean you're just another committer on that branch now as far as changes go. So
okay. I
will say that the first person to push is going to be happier than the rest. But let's give it a shot. Yeah, give it a shot, and we'll reconvene in about 15 minutes or so and see how it went.
Cool. Thank you.
Sure. Okay, how's it going with the diehard folks who are still here? Any success in pushing and collaborating on changes?
Looks like everyone's in the breakout rooms.
Oh, okay. Awesome. I'll give it a few more minutes in.
Yeah,
but on the other hand, they're all interleaved. So you're going to get some of the same experience, when some of your changes are going to be interleaved with other changes that need to go on too. So you'll have to do some merging of your content in order to make it all work together as one website or one page or whatever you're working on. So this some of this is real, some of it's artificial, but these branches are just there to give you something to look at as far as what tasks, you can say they represent individual tasks that could have all come off the same place down here, potentially.
Okay, that makes a lot of sense.
You can work with those branches or not as you choose. I would definitely not focus on you don't want to change, don't like check them out and make changes on them. I wouldn't go that route. That's not what they're there for. They're only to represent tasks for your collaborative project. You would actually, each of you make changes on master, for instance, is one workflow you could do. And then what I expect would have happened is if you did that and then, say, Michael, you pushed your change up first and you got in there because you were first. So it got into your team lead's repo. And then Jason, you tried to push your change, but you had not pulled yet. So you conflicted with Michael's change, which now means you've got to do a git pull, which would require a merge, which is what a git pull will try to do if you let it. It'll try to merge by pulling down the changes and then putting them on master where you're at. But you may get a conflict at that point as well, a merge collision. And then you have to sort that out and take your local changes and get them all like they should be, and then commit those and push up again. And hopefully nobody's pushed already, because then you have to do it again. So you'll start to see some of those challenges as you use Git in a real life kind of collaborative situation. And we'll do more of that tomorrow. What I've given you today gives you the basis for the foundation for being able to work out those issues that will come up when you begin to collaborate with Git. And really, those aren't even Git issues. Those are just issues of collaboration. And Git is a tool for you to manage them and quantify them. So, but we have to get past the basics of the tool first in order to think at the level of the problem domain of the project that you're trying to collaborate on, the changes you're trying to make together, and how to keep organized.
So Chris, I have a question.
Yeah.
So what you're saying is, let's say I was collaborating with 3 or 4 people, before I was really going to push anything up, it would actually be beneficial if I always had something like Sourcetree up, like the tree up, to see if I needed to pull down a change from one of my coworkers before I pushed up. So that's going to become common practice when we work somewhere and we collaborate with teams. Yeah.
Notice. I haven't tried this as far as live behavior, but there's this fetch option up on Sourcetree and probably on Git Graph too. And what that does is update your representation of what's out there locally, but it doesn't actually merge anything in. It's basically the first half of a Git pull, right? Because a pull is, well, we haven't covered this, but a pull is a fetch and a merge. If you just want to do the fetch, right, you can just see if those things have changed up there and decide what to do from there. So your origin master is what we care about, right? Because that's where you're rendezvousing on, is origin master. And then you can decide if you want to go ahead and merge or whatever. which you can do graphically, or we'll use the command line as well tomorrow to do that. So,
Hey, Chris, I have a quick question for you.
Yeah.
So two of my teammates were able to commit things pretty easily, and I was able to see it, or able to push things through. Whenever I tried to push, I got a fatal, the current branch master has no upstream branch. And I used I found some on Google that was like git push origin master -- force, and it kind of overwrote everything. Yeah. Any,
you're that guy.
Exactly. Just hostile takeover.
Take my changes, ignore all the others. I don't care. Yep, that's what it
In
does.
Duncan's defense, they've been telling us to Google everything and just go with it. So,
yeah. So, do you have any recommendations on what the issue might be, or?
Yeah. So a git merge pulls down changes, and then you get collisions, and you can resolve them. A git push cannot resolve those changes if there's any like divergence on the branches, which there will be if somebody else has pushed before you. Like a git push just says, "Oh, there's divergences, I quit." Now, a git push origin master is the right command to run. That's fine. There's no harm in that command, but it will still fail if somebody else has pushed before you, which means you'll need to do a git pull origin master and grab those changes and work with them locally and meld them into what you've changed, commit all that, and then try to git push origin master again. Don't use force. We'll cover why tomorrow, but yeah, that's why. Good question. Excellent question.
And then so it says automatic merge failed, fix conflicts, and then commit the result. So it's saying just collaborate with the team, find out what those conflicks are, and then I'll be able to push. Is that?
Yeah, I mean, sometimes you can figure out on your own, right? If you just do a git pull and you see we'll work through an exercise or two in like going through the collisions that happen and what they're saying. Pretty often you can figure out what's going on and just commit. Sometimes you do need to, open a separate channel and talk about why so-and-so made this change in this way and why yours is better. But usually you can just see what's going on and go ahead and, interleave what they're doing with what you're doing and, push it all back up in an integrated way. Yeah, good question. So, open to more questions.
Yeah. What's the opposite of that? Like, how would you, if you had a change that you were like, screw it, I just want to have the latest version, the correct version again? What's that?
Like throw away local changes?
Yeah. How would you just force the git of the latest version?
Well, so if you do the fetch, you'll see it, right? If you do this fetch, then everything that's origin is like from your origin, is from github.com.
Is it possible? Is what you just did possible without that program?
Yeah, just do git space fetch command line. Does the same thing. I haven't shown you this, but there's an alias called adog, which basically shows you exactly what Sourcetree does, except from a terminal, kind of a terminal terrible graphic sort of way, but it's all the same stuff, right? These lines and stars are the commits and where they're connected to and all that. You can see the graph. They're trying to draw the graph the way it does. So it's all the same stuff. But yeah, if you wanted to like say this add mild styling was the place you wanted it to be, and let's not use that. Let's say master had gone somewhere else, like this origin master. Let's can I mimic this? Now let me just hand wave. So say origin master was somewhere up here. You have the tools that we looked at today with Git Reset. If you're on your master, you can just do a Git Reset -- hard origin master, and it'll go there, and that's where your master will be.
So Git Reset -- hard pulls the latest version that's shared onto your local version.
Not exactly. It doesn't do any pulling. It goes to a place in your local graph that you tell it to. And it takes along your head, your index, and your workspace. That's what hard means. Like, so it's like, let's all go here. So you have to do the git fetch first so you know where here is. If there's some, there's some changes that have been made up there, fetch puts them into your repo, but it doesn't put them into your workspace or your index or your head. It just says here they are. Like that's what these origin slash references mean, is that's what it's saying. That's what it's like on origin. So you can go to it because you can see it, right? There's a commit you can see. If there's a commit you can see, then you can go to it and you can put a branch on it. You can move your master there. You can create a new one there. You can make your graph look like you want it to. But everything that's origin is, you can't change that directly. You don't work on that directly. You can go look at it, but you don't commit to it because it's just a pointer to what's out there on github.com. That's why when you do Git Checkout, add a form, for instance. So if I said Git Checkout, add a form, it switches to the branch, but it has to make one first because there's only origin / add a form, which is just a pointer to what's out there. So it has to make one here, right? That's now at the same commit. Now you can work with this a local branch, right? There's no origin / on this. It's just add a form. That's a completely different branch, even though it points to the exact same commit. So if I start to make changes on it, like if I start to code, let's go to manage.py again and make a change, right? Go back here, git status. There it is. Git add. Let's use my alias GA for git add. Git commit. Okay, now where are we at? Right here. So my local branch has moved. Oh, and it tells us I'm one ahead. So I'm one ahead of where it started. This guy's still back here. I haven't done any pushes, and that's the only way to really change that branch remotely is to push to it, right? So if I push to it, then it would jump up here, but I can't just go, I can't do a git checkout origins. I mean, I can, let's see what happens there. Origin / add a form. It's like, oh, okay, are you sure you want to do this? And it lets me do it, but it says I can look around, I can, make changes, but yeah, pushing is not a thing with this. So, it's not a normal workflow to directly check out a pointer to a remote branch. It will make you a local one to track it right here. That's what you normally do. And then you can push. Because it's tracking that remote branch. So when you push it, it says, "Oh, you must want to go here," right? Because that's what you're tracking with your local branch. It's a little weird, maybe a lot weird, but you get used to it. But local remote branches are different. They're different branches, even though they kind of operate together with pushes and pulls. So when you have a master, you have a local master. It's another way to, this master you're working on is this one, not the origin / master. If I start making changes, and master is going to start going on its own direction. And if somebody else makes changes and pushes, then origin master is going to go on its own direction from those remote collaboration changes. And then that's when you have to merge back in to get back together in the same place again. And you'll see that in action tomorrow. Let me call it here and remind you to try to go, if you haven't already, which you probably haven't, go through the student handout, the objects and trees handout. It's most of what we've covered today, but deserves, repeating, deserves soaking in a little bit, because you've had a lot thrown at you. And we'll embed some more in tomorrow and bring in some workflow tools as well as we work through this tomorrow. So anything else before we close for tonight?
Where exactly is that student handout?
Yeah, so that's the object and trees. If you go back to this github.io/tags, there is a link. The object and trees handout link. I can actually put that on the Slack. That's probably a good place for it.
That'd be great. Thank you.
Yeah, there you go. So, yeah, take a look through there. We will come in at 9 a.m. tomorrow and begin to look at how to, manage how to do merges and resolve collisions and stuff like that. Duncan, were you speaking? You're on mute. So.
Yeah, no, I'm sorry. I was yelling at my computer to work.
Cool.
So if we do have a lot of branches and a lot of craziness in our Git right now, is there an easy way to delete it all, or do we just delete the whole thing, repull?
Yes, so that's an excellent question. The answer is yes. Git will only show you things that have a branch attached to it. So if you have a bunch of changes on master and you do that reset, then those changes, if you change master back to here and there's no branch pointing up there anymore, those they won't go away, but they won't be visible. They'll still be in Git, but Git's like, well, you don't care about it because there's no branch pointing to them, so I'm not going to show them. You change your mind, there's like a log you can go back to. I'll talk about that tomorrow. If you really need to recover that, you're like, oh, that was a mistake. You can go back and see where you used to be pointing. But for all practical purposes, once there's no branch pointing to it, Git forgets about it. It doesn't think it needs to show it to you anymore. So that's one way to throw away changes, is just delete the branch or move the branch somewhere that that's a known good point, for instance.
And I'm assuming everyone on the team has to do the same thing to make it go away.
Well, that's a good point as well. It depends how you share, because like if you do the Duncan force push method, then his wins. Force push wins always. There are ways on GitHub to stop that. You can do branch protections, but yeah, you have to think through how is this going to impact the team? Because when I do resets around, that's fine for me locally, but it's going to have an impact on whether I can effectively work with the rest of this team. So you have to think about kind of where they are, and what you want. Maybe all of you need to go to a different place together, and then you kind of go off channel and say, okay, everybody, I'm going to do a force push. Let's all check out from this place right here and throw away what you had before, and here we go. But you have to think that through before you do something like that.
Thank you.
So yeah, we'll go through some exercises on that tomorrow, on like rebasing and squashing down your commits, and when it's a good idea and when not. Well, thanks for your time, everyone. Thanks for hanging with me this long. It's